In this video, I'll provide you all the required instruction for completing the lab, which is about the measuring of an acceleration of an elevator. So you should be able to measure the acceleration of an elevator by using the simple tools, and the only tool that is required here is a weighing scale. So if you have this scale, then you should be able to measure the acceleration of an elevator. So let's do that. Before jumping into the experiment or the numbers, you have to answer all the pre-lab questions here. So all the pre-lab questions, the differences between mass and weight, what is the formula for calculating the acceleration of an elevator. I already have made the videos. All you have to do is watch those videos and answer all this question. Okay? And you can do it by watching all these videos. So here I'm going to get started with the measuring the acceleration of an elevator. So the first thing you have to do, take a mass and measure the mass in an elevator or even outside when the elevator is not moving up or down or the elevator is at rest. So what you do, you have this elevator, okay, and this is your mass. So this is your mass or weighing scale. And then when the elevator is at rest, you measure this mass, or you take a note of the reading when the elevator is not moving. So that reading, let's say, is 1000 gram. I am starting with 1000 gram here. You can choose any mass you like to. So if I change into kilogram, it will be 1 kilogram. Just for your understanding, a weighing scale can never measure the mass, but there is a calculation going inside that reflects you the mass. Okay, so here I'm simply calling this one as a reading by the weighing scale when it is or when the elevator is not moving. So once you have this reading, the 1 kilogram, this reading is from the weighing scale when the elevator is not moving. I'm simply going to multiply by 9.8, and this would be 9.8 Newton. All right. So now the next step is, now you have the buttons here. You press the button and the elevator starts moving up. Okay. And then what you will do, you will record the reading of this weighing scale here. It starts making all the videos. And the reason is because the numbers might change quickly. So if you have the video, then you will notice the number changes. So you can measure, you can get the accurate value of it. So when this elevator starts moving, you will see this value here and record that value when the elevator starts moving up, just when you started. Let's say this number is 1100 gram, and if I change into kilogram, it will be 1.1 kilogram. All right. Okay. And then you have to do repeat 3 times. Okay. The repeat 3 times means you press this button, the elevator goes up the top floor, come back here again, and then it starts doing just taking the measurement. You have to do it 3 times. All right. So let's say in my case, one time I got 1.1 kilogram. I got, let's say, 1.15 kilogram, and the other time, let's say, I'm getting 1.05 kilogram. Just making up numbers here. All right. So if I do the average of all this number, in order to do average, add all this number together and divide it by 3. Okay. So if you add all this number, or if you want to measure the average, you will have to do 1.1 plus 1.15 plus 1.05 and divided by 3. So just do that calculation and see what's the number you get. So again, this number would be 1.1 kilogram. All right. And I have to change this kilogram into the weight, or the multiply this one by g, and this number would be 1.1 times 9.8. That's the n value here. All right. So now once I have all this observation, I can simply plug in and calculate the acceleration. Here is the formula. How do I get this formula? Just watch the video and then you should be able to find it out. So n value here is 1.1 times 9.8. Let's multiply it. And I get 10.78. 1.1 times 9.8. 10.78. That's right. 10.78. So I have n. This n as a 10.78. So let's plug in. My mg, I already have calculated this mg here. You see this mg already have calculated, that is 9.8. So 9.8 divided by this mass. This mass here is 1 kilogram. So 1. So let's do the calculation. What I get is 0.98, and the unit has to be meter per second square. So this way I found out the acceleration. Your number could be different depending upon the building, like how fast the elevator, depending upon the acceleration of the elevator. So your reading and this reading could be way different. All right. So exactly the same way you have to fill out all these tables here too. Okay. So exactly the same thing. Just record all this number, plug it into this equation, and you will get the acceleration. And in this case, when the elevator is going up and it's about to slow down. So let's say if this is your elevator. This is your elevator. Okay, so you have first press the button here. The elevator starts moving up. And then when it is about to slow down, let's say you went to the third floor. And then when it is about to stop, then you will also see a change in the number. And that number you have to record it here. You have to record it here. Okay. And then once you have, again, do exactly the same process, and you will have this number here too. And of course, you will get the negative numbers. So why you get the negative, I'll simply explain here. So this all, in my case, I have chosen all my upward direction as a positive, all my downward direction as a negative. All right. So when I choose all the upward direction as a positive, and this when the elevator is going up, then first it will have a positive acceleration because it is just speeding up. And when it is about to reach to the top floor, it has to slow down. The slowing down means what? The acceleration has to be opposite to the direction of velocity. So that's the reason you'll get the negative. Or simply the negative acceleration means it is slowing down. Okay, and exactly the same process. These two measurements were for the elevator going up. In this case, it was speeding up, and in this case, it is slowing down. And now you have exactly the elevator is going down, but this time is speeding up, and this time is slowing down. So just take all those 4 measurements, and for each measurement here, you have to do the 3 trials and find out the value of acceleration. So this is it from this video. If you have any question, if there are any things that you think you have not understood, get back to me and I will get back to you. Okay, so thank you guys. Have a wonderful time, and do not forget to like, share, and subscribe the channel. Thank you.